Hello again. In our first three lessons, we studied the sine and cosine graphs. In today's lesson, we're going to study the other four trig functions graphs: tangent, cotangent, secant, and cosecant. Let's start with the tangent graph. First thing that I'd like us to do is look at a 45, 45, 90 degree triangle. This 45 degrees in radians is pi over 4. If we were to take the tangent of 45 degrees, we would see that its y over x is 1 over 1, or 1. So what that means is that when we graph an x value of pi over 4, that our y value is going to be 1. Now if we did a negative pi over 4, that would be a negative 45 degrees. And so we'd have a 45, 45, 90 triangle again, and the y over x would also, in this case, would equal a negative 1. And so we've got negative 1 there. The tangent of 0 is 0. And as we get closer and closer to an angle of 90 degrees, our tangent values get super huge. This has to do with the relationship between the sine graph and the cosine graph. In any case, we've got a vertical asymptote there at pi over 2 and negative pi over 2. So the same pattern holds, that if we go another pi radians over from our first asymptote, we're going to have another asymptote, which I'll put in red, even though words probably not going to like some of these dashes. You'll get the point. Same thing at negative 3 pi over 2. We have another asymptote there. And a curve in between. The intercept happens halfway in between the two asymptotes. And we'd have another curve like these. Now what I notice here then is that this graph repeats every pi units. 0, pi, we'd have another asymptote at 2 pi, and so forth. Period of this graph is pi. Now that's different than the period of the sine and cosine graphs, each of which is 2 pi. So then, when we have an equation and we've got a b in that equation, remember for sine and cosine we'd have to do 2 pi over b. For tangent graphs, the period is computed by doing pi over b. Alright. Next thing that I'd like to do is the domain. So the domain is all the possible x values for a graph. Now, most x values can go into the tangent graph. Any x values except pi over 2 will work, and 3 pi over 2, and 5 pi over 2, and 7 pi over 2, and negative pi over 2, etc. So you need a way to describe all the numbers except those multiples of pi over 2. Not really multiples of pi over 2, but those numbers related to this pi over 2 here. So first, I'm going to start by saying that the domain is all real numbers except, so we're going to accept pi over 2. Now if you take pi over 2 and add pi to it, you get 3 pi over 2. If you add 2 pi to it, you'll get 5 pi over 2. Add 3 pi to it, you'll get 7 pi over 2, etc. So by adding all the multiples of pi, that'll get you the numbers that are accepted. So this is the way that I'm going to describe all the multiples of pi. Pi times some number k. This expression gives me a multiple of pi, which I can then add to pi over 2. Now we need to describe what sort of number k is. Now k is an integer, so I'm going to use this notation. K is an element, looks sort of like the euro symbol. K is an element of the integers, sort of the bold-faced Z here. Now the range. The range is all the possible y values, and those will include all real numbers, because this graph goes down forever, and it goes up forever. So this would be all real numbers, negative infinity to infinity. I'm going to skip this part here. I was going to have us do the tangent graph, but on the an axis that's labeled with the integers instead of multiples of pi over 2. So we'll just skip that part. This next one, we want to write an equation for the graph. To write an equation for the graph, it's helpful to have a general equation. So this general equation looks a lot like the general sine and cosine equations. The tangent of b, except that doesn't look like a b, it looks more like, I don't know what it looked like. Tangent of b times x minus some number h plus that midline tacked onto the end. Alright, so first off, the midline. Midline for a tangent graph is the place at which the graph changes direction from sort of being curved upward to being curved downward. Sort of the cuppedness. You can see this sort of cupped up, this one sort of cupped down. Now the midline for this graph is right here. It's the x-axis, which is the equation y equals 0. Just like when our midline was y equals 0 for sine and cosine, we don't really have to add anything. I'm just going to write a plus 0 there, so remember that we've done it. Alright, next, this amplitude number right here. Amplitude, remember, is our vertical stretch that's going on. Now notice how this tangent graph changes its cuppedness, so to speak, at a value, let me back up a little bit. Halfway in between the intercept, where it crosses the midline, and the asymptote, it has a y value of 1. So what's the y value halfway between the intercept right here and this asymptote right here? So that y value halfway between the intercept and the asymptote is this point right here, which has a y value of 2 instead of a y value of 1 like we see here. And so this amplitude is going to be a 2. Essentially, we've got a vertical stretch going on with this tangent graph. Alright, next up, is there any sort of horizontal shift going on? Well, I see that my curve, my tangent curve, is going through the y-axis and the x-axis at the same time at the origin here. Same sort of thing happens here with a basic graph. If this point here were shifted over to the right or to the left, then we'd have to do a h number here. But there's no horizontal shift going on, so just write a minus 0 there. Next up, this period, the b, which helps us get our period. So notice how a typical graph, we had said the period is the distance between these two asymptotes, which would be pi units. This one, our distance between our two asymptotes, is 8 units, from -4 to 4. So the period is 8 units. So when I ask myself, pi over b needs to equal 8 units. So what does b need to equal? Let's multiply both sides by b, and then divide both sides by 8. That would give us pi over 8 must be our b. And of course, you can clean this expression up by rewriting this as 2 times the tangent of pi over 8. Then x minus 0 is the same as x. Plus 0 you don't need to write. And so we've got that one. Next up, 3 times tangent of pi over 6 theta. So notice that we don't have any plus something going on, so our midline is going to be right here. Next up, the amplitude is 3, and the period will be pi over b, which is pi over 6. So we'll keep, change, flip. That's going to equal 6. So the period is 6 units. So the distance between these vertical asymptotes is going to be 6, meaning that we'll cross these vertical asymptotes will be located at 3 and negative 3. Now this amplitude is 3, meaning that the point halfway in between the intercept and the asymptote is going to have a y value of the amplitude, which is 3. So halfway between 0 and 3 is 1.5. So the y value there needs to be 3. Negative 1.5, negative 3. Crossing at the origin, and then we draw our curve. Of course, we need to repeat this over here. Period is 6, so from 3 to 9 would give us 6 units. Then the intercept will be halfway in between those two asymptotes. From 3 to 9, halfway in between that would be 6. Halfway in between, negative 6. And then 7.5, 3, 4.5, negative 3, and so forth. And we go on from there. Next one's the cotangent graph. See, the cotangent graph looks a lot like the tangent graph, except the curves swoop in the other direction. Instead of going up on the right and down on the left, these go up on the left and down on the right. Also, the asymptotes are in different locations. The asymptotes are at 0, pi, 2 pi, and so forth, and the intercepts are at, this is about 1.57, which is pi over 2. This is 3 pi over 2, and so forth. I'd like to point out that the intercepts of cotangent are where the asymptotes of tangent are, and vice versa. So we have negative pi over 2 and so forth. So these asymptotes are here. The period of a cotangent graph, it repeats after pi units. The domain is all real numbers except all the multiples. Yikes. Good luck trying to read that. It says except. Anyway, so it's going to be all real numbers except for the asymptotes at pi, at 2 pi, at 3 pi, and so forth. So it's going to be all real numbers except pi, plus all the multiples of pi. So that would just be pi times k, where k is an integer. The range will be all real numbers because the graphs extend forever up and forever down. Negative infinity to infinity. All right. Video 2 will take us to the back page.